Hello everyone, welcome to Demystifying App Architecture, the LeanCode guide. I'm Mateusz, I'm head of mobile at LeanCode, also Flutter and Dart GDE, been into Flutter since early beta, I think. Yes, okay, thanks. Been into Flutter since early beta And
I'm Marcin, I'm senior Flutter developer at LeanCode.
Yeah, and you can find us on X, Twitter, using those handles. So, over the last year or two, at LeanCode, we've built over 40 Flutter apps. And there are lots of apps that are not related to each other in any domain or niche. There are startups, there are scale-ups, there are large-scale enterprises, there are B2C apps, there are B2B apps. So we need to be prepared to build the app and the architecture for the app for any kind of the app. So what are our assumptions as LeanCode? We need to have a quick start. So have all the common features from day one, because why write them, again and again and again? Everyone likes it. We want to be able to scale in terms of people. So if we need more developers or the client wants to, grow faster, we want to be able to do that. And we want to reuse code, right, between those projects. So we want to have packages that we can fix in one place, fix the bug in one place. And of all architectural drivers, the most important for us are maintainability. So how easy it is to, fix and work with current code, and extensibility. So how easy it is to add new features. And all of those, of course, without any compromise on quality. So as you might think, we also have our own app templates so that we have this quick start. So we have authentication with Kratos on the backend. We have navigation with deep links, push notifications, API client setup, CI/CD setup, App Store, Play Store, all that stuff, provisioning. Also, from the beginning, we have design system package as a separate package, so that the app package depends on it. We have also diagnostic stuff like, loggers, Crashlytics, debug page. This is this bug icon where our QA engineers can just look inside the requests, logs, and stuff. And many, many more, as you will see. So what's our architecture? We will go through a couple of milestones and areas. So let's start with project structure, because I think that it all starts with project structure. So we are very dedicated to feature-based architecture. So what it means, when you look at project structure, you could look, there are two main, most popular ways of looking at that. So at the left side, you can see the screenshot where all the directories are named after some business terms, like rankings is some business term. This is some sport app, mini rankings, team, join team, team editor. And on the right side, as you can see, all the directories are about technical stuff like blocks, data, pages. So layer-based architecture, which you can see also in very popular, videos, articles, books, is where you have this. And in our scenario, when we used that approach, it's very hard to split into multiple packages because you don't know which files are related to each other. The pro might be that you don't have to think where to put the file, because if it's block, you just put it into blocks directory. But actually, it might also be considered as a con, because it's like with naming classes. You know how hard it is, but also you know how essential it is to name it. So with files, it's the same. If you think where to put it, the more you think about it, you think about how it's related to other files, other features, is it shared across features, and so on. And it scales really bad. If we start with a simple app and we want to have a large scale app, imagine having 200 blocks in one directory and you don't know which one is which. And it's hard to tell how big is the feature. This is really a nice one. It's hard to tell if, for example, active contest is actually something that has a couple of files, the feature, or is it one of the main features? You don't know by just looking at it. And also it's hard to be new in the team. If you onboard new developers and, for example, you want to tell them, okay, look around active contests and fix a bug, they still have to visually go through the whole code base. On the other hand, we have feature-based architecture, which means that we are domain-oriented. We have directories named after business terms, business scenarios, user stories, and how they're related to each other. There also can be sub-features inside. You can encapsulate some of the sub-feature logic. All of things related to this feature or sub-feature is encapsulated, all the code inside this directory. So it's easy to onboard new devs because you can just say, okay, go to this directory of contest statistics preview and look around, and they know, okay, all the code that I have to learn at the beginning is in this directory. It's convenient to add new features because you just add another directory. And if you have too many directories, you can also scale. I will tell more about it in the end of the presentation. And it's easy to assess the complexity of the feature because if you see the feature that has 5 sub-features with 10 files each, you can see that this is some core functionality. It's probably a huge part of the app that's really important. And on the other side, you can see something that has 2 files and you know that this is just a simple page or something. So there are no silver bullets, right? And in architecture, it's even more crucial that there are no silver bullets. So we aren't here today to say this is the perfect architecture because it's not. It's in our scenario, it's just our blueprint for the perfect architecture. So we start from this that we are talking about today, and then we will show you that no matter how in what direction we have to go and what custom non-trivial stuff we have to cover, it's still viable if you start from it. Okay, so let's go to another important stuff.
Okay, so now let's take a look at state management. And long story short, for state management, block is our default choice. We want to have some standard that we can use across projects that all developers know and know how to use. So this was what we started with. This was still stick with it. And why block? Because we find that it's easy and simple and easy to understand. The principle of blocks are very simple. It's just a class that holds some states and can emit a new state. It's easy to explain to new developers. It's scalable. We use this in a big enterprise project and it never failed us. So that's why we find it very scalable. It's predictable, easy to test. You just have to look at the list of states that's emitted and assert that. The thing with block is that it can be boilerplatey. And over the years, we realized we were actually duplicating a lot of stuff in our projects. But we also built some tooling to reduce that. And we're going to show you that later in the talk. And an important note, because block is both the name of the library and the name of the base class, we actually use qubits. It's part of the block library, but kind of a different way to achieve the same thing. They are enough. In over 95% cases, we very rarely use the row block. We typically only use qubits. And for local state management, we prefer hooks over stateful widgets. This is now our company policy that in all of our projects, we start with hooks. And you might know hooks from the Flutter hooks package, like the most famous one, use state, which replaces state from stateful widget. There are also some other very useful hooks like use text editing controller, use focus node. But we also have some of our own patterns that are based on hooks that we created. So let's take a look at this piece of code. This is how you would typically declare a block that is scoped for some screen. So here we have some page. We have to create a block provider where we initialize the qubit, and then we need some other widget that actually can access this block via build context. But what we typically do in our projects is that we just use a single widget that is a hook widget. And we declare qubit with the use block hook, which takes care of initializing the qubit when the widget is initialized and disposing it when the widget is destroyed, removed from the tree. And the thing is that we actually, because of that, we have to pass explicit dependency to block builder, block listener, another widget if it needs to be passed further down the tree. But we find this actually an advantage because the thing with provider is that if you're accessing something, you never really know if it has been declared above in the tree. And if you provide explicit dependency, you have the assurance that this actually exists. And the power of hooks also comes in hooks that are for a project. So this is example from my current project. This is some hook code, use auto refresh profile status. It takes care of some logic that is dependent on the widget lifecycle. And looking at this widget, you don't really need to know what's happening inside unless it's something that you're interested at this moment. And it can be very easily reused across multiple widgets. And if this was a stateful widget, you would have this code split into multiple places. It would be really hard to share between multiple widgets. So that's where the real power of hooks comes. And yeah, so the summary of hooks. We use hooks by default in our projects. They reduce the boilerplate of stateful widgets a lot. They make it easy to share lifecycle dependent logic between widgets. We also use some custom lints to catch misuses of React hooks. We're going to talk about this, Flutter hooks. We're going to talk about this a bit later on. And also hooks are not perfect, so you can use them wrong, and it's actually very easy to do if you're not that familiar with them. So that is actually a disadvantage of hooks. A typical thing that we also seen in some of our projects is that it's very easy to add use effect to a widget and make some logic. That's very convenient, but that can also be overused a lot. So you can end up with a very long widgets with a lot of logic that no one then understands because it's all happening. Different pieces of logic are in different places. So you actually need to be careful with hooks. And we have LeanCode hooks package, which contains all of our most used hooks.
Yeah, the second important stuff that I think is very much related is dependency injection. So this is like in Flutter world, there are two popular ways of doing dependency injection, right? The first one is provider. Here's with block because we use block as our global state management tool. But what's provider doing? It just binds an object instance to some its lifecycle to some widget lifecycle, which is very convenient in many cases. So, for example, as you can see here with block provider, the pros are it will get disposed with the widget. So it's very great if you have a block that's related to some widget like a screen, a page, a feature, some widget subtree, and you know that the lifecycle of this object, this block, should be the same. Then it's very, very straightforward. It just gets disposed and everything works. But you can, with global stuff, it's harder because you have to pollute your widget tree with a lot of providers, and you have 100 providers for global stuff, which is very cumbersome. And beware of deep provider widget nesting, because in one enterprise project, we had a lot of global providers that were there, and we had some performance issues, some tooling issues because of the tree nesting, and we had to do some workarounds and hacks. So if you have global stuff, Get is the most popular way because it's just a service locator, the most popular service locator, and it can be used without Flutter, and you don't have to think about your widget structure. You just want to have a bag of dependencies and just get something. So it's really convenient for things like API client or local storage, something like which is infrastructure for your whole app. But it would be nice to have the best of the both worlds. So a colleague of us, Tomek, he's on at the LeanCode booth. You can check out his work. He's now working on Spyglass, which tries to merge both approaches. So with Spyglass, you can either have a dependency that's injected into tree and bound to the widget lifecycle, but also you can have a bag of dependencies that are global. But no matter which one you use of those, in the architecture, from the architecture perspective, the most important is how you use it. So this is, for example, something that's really important for us. Don't resolve your dependencies inside. It's called dependency injection for a reason. You want to inject the dependency because, for example, look at this code. It's really like you have a user preferences qubit and you have a parameterless constructor. So for someone that's from the outside, like external developer, they see it and they think, okay, this has no external dependencies, right? It's just, pure in a way. But it's not true because inside you have local storage, which is your dependency. And also now you have a get-it dependency. So you have two dependencies implicitly. You have a service locator, which probably is not needed. And like in business-wise, it's not your dependency at all. User preferences shouldn't depend on some service locator stuff or infrastructure. So just if you just pass it to your constructor, no matter what DI solution you use, is just okay, because it's much mockable, testable, maintainable for other people.
Okay, so now let's take a look at how we integrate with APIs in our project. And we basically have one very important tip, that you should always generate API contracts. You shouldn't really need to write it yourself. The declaration of endpoints, all the models, it's both a waste of time and can cause trouble when the state of backend and state of frontend gets desynchronized. So if we have our own backend built by LeanCode team in .NET, we have a special code generator for their contracts. In other projects, when you integrate with external APIs, we typically use OpenAPI. You can easily generate from JSON files Dart clients. And when you write code, you just have some profile API object, and it lists you available endpoints, and you just pass them a model. So it's just very simple, and I think you should always do that. And now let's move on to UI. And UI is a bit tricky because on one hand, design for every app is different. So every app wants to look different. We don't want to have all apps look the same. But on the other hand, we know that we actually write the same things over and over again. So every app needs a text field. Every app needs a button. It's very similar. So we thought how we want to tackle this, because we really wanted to optimize this. So we realized that we should have some robust, highly reusable set of UI components that can be easily adapted to a new project when we started. Also, we don't want to be limited by what's in material. So it's something cannot be done with material component. We want to have something that we can easily change without forking the material widget. Typical example is a text field. So we had a lot of projects where we couldn't just use material text field because the design used some features that are not easily possible with a material text field without forking it and operating on the render object level. We also want to avoid analyzing common UX patterns in every project, and also provide good accessibility by default. And what we ended up with is our own design system template. As you can see, we use Widgetbook for development and testing. And here we have some app text fields that we analyzed our projects, how the UI, and we try to find every case that can appear, basically. So this is, of course, you can see there are a lot of options there. Probably you don't use them at all. You would never use them all at once like here. But this is just to show that we try to solve some UI problems that can appear and make it easy for developers starting new project to start with this implementation and tweak it to the project needs. So our design system template, it's a separate Dart package that we copy to a new project. It contains all common UI components that are typically used in mobile apps. As you've seen, it tries to handle many different variants of those components. It's also tested with widget and golden tests. So if you change it, if you try to adapt it, you can be sure that you don't break some existing combination of properties, because with complex component, it's very easy to do. It also supports assets compression with our WebP package. We also fetch icons from Figma files, so you don't have to copy them. We use Figma API for that. And an important point, because you might think it's something like a new material done better, it is really not. It's not meant to be reused as is. It's just meant to be a base implementation. This is also not blank canvas. This is not a set of primitive components from you can build complex components. Those are actually quite complex components. So the idea is you just copy the code from the template and change it as you wish. So you just have a starting point, a full implementation of a text field, and you can just, if you don't need something, you can remove it, you can rewrite it. But we found that it still saves a lot of time, even though you still need to change it. So, for example, if you start with our template button, you can change borders, text sizes. You can remove those icons if you don't need them. You can also make something more fancy, like on the right side. But this is a very good starting point for a new project. So we went through our base points of our architecture, and now we wanted to show you how we actually build stuff using all of that. So let's take a look at some common feature scenario. So let's take a classic example, a paginated list, things that you do a lot in every project. So let's start with state management. We need some, let's take orders as an example. It doesn't really matter in this case. So you can see this orders qubit actually extends some paginated query qubit. And this qubit is part of our LeanCode qubit utils package. So you can actually see that pieces of our architecture come together. So we use blocks, so we optimize for things that are for qubits. So this base class, we need to just override two methods. One is request page, where we call the API, and the API client is generated. So we just call some method, pass arguments, and basically that's all of that. That's the minimum boilerplate that you need. And the other thing is mapping. So you might want to use some different object. You might to do something with the list, like filter it on the front end side, whatever. So on-page result gives you the way to do this. And this is basically the whole state management that you need for a paginated list. Everything is handled inside, like errors, loading states, keeping the track of which page is fetched and which page needs to be fetched next. And on the UI level, we have some orders page. We create a route. This is standard Flutter stuff. You might see something new here. So we use something like page ID. And this is something that we want to get deeper into that, but we have some built-in analytics. So based on those page IDs, we are actually automatically collecting some events like taps on buttons and stuff like that, and also renders of pages. And we can also have a starting point for some more complex analytics. Then you can see that we declare the qubit with use block, as I've told you. So again, this is something that you would see in all of our projects. And paginated qubit layout is also part of this LeanCode qubit utils package. And it takes care, again, of the loading state, error state. This can be defined globally in some config, so you don't have to repeat it in all of your pages. And you can see a lot of app prefixed widgets, and those come from our design system package. So you can see some app scaffold, app top bar. So those are actually our components that we should use instead of default Flutter ones. And actually, this piece of code that you see here, this wouldn't pass our analysis because we don't want to use raw text from Flutter. We want to use app text, which is our wrapper. Why is that? Because we don't want to allow using arbitrary text styles in our project. Text styles that can be used should be defined by the designer, and we should use only predefined app text styles to keep the app consistent. And this lint is part of our LeanCode lint package. We actually have a challenge, so you can come to our booth and try to break one lint. We know it's not perfect, and there are some very niche edge cases. You might also find new ones. And this lint package, basically, this actual lint is called use design system item. So here you can define that, for example, we don't want to use text field from Flutter package. We want to use app text field, and so on, for different things like colors, icons, and stuff like that. So you can see that we are actually building UI from ready-made blocks. So developers working on business features, they don't need to care about how the UI works underneath. They can focus on just creating a new list. And there are actually some interesting things here if you look closer. So for app text field, we have a similar pattern as material. We have some decoration, but it's our wrapper, app text field decoration, which again only allows passing colors that are defined for the project. Again, with rendering an icon, we again only use context colors, foreground success primary, for example. And those colors that come from context because they can be in dark mode or light mode. So that's handled on this level. Again, the sizes are also predefined. So we don't want to pass arbitrary double here because we don't want to have one icon to be 15 pixels and the other 18. We want to have some standard like 16. And you can see that semantics label is actually required in those widgets. So you cannot just skip it. You have to provide a semantics label or pass null if it's actually it actually makes sense in some rare scenarios. So we are basically building UI from ready-made blocks because we want to keep the design consistent. So as you can see, we have some wrappers. We want to have a strict API, which doesn't allow breaking standards set by the designer. We also have lints where compilation cannot do it, cannot provide everything. And it's also for developers so that they can focus on writing business features and not dealing with low-level stuff. It can be a developer that really likes UI who then tweaks everything underneath. So we can polish this UI independently, and it's not blocking development of business features.
Yeah, so now we covered like 80% of daily development because, you know, it's the bread and butter of doing single requests, pages, and paginated lists, so that we have time for doing the actual fun stuff. So you might ask, okay, so what if something non-trivial happens? So, for example, what if it becomes large scale? In this architecture, what we do, if, for example, we have, like, you can see the banking app, you have a lot of features, and business people come and they say, okay, onboarding is something that we want to reuse across multiple apps because, you know, legal stuff, banking and onboarding is very special. You have know your customer flow and all that stuff, personal business clients, and you already wrote that in one package, in one app. So, okay, it's actually this feature is so big and it's so independent in the business perspective that it also should be independent in the code perspective because we are business oriented. So we extract it to another package, and you just take the code from this directory. So this is easy. And you might think, okay, but I depend on some API client or other infrastructure stuff that already was in this package. Yes. So if you extract the first one, then you have to deal with that. You have to extract some shared code, also like API client or cache. But once you do that, every other extraction is much easier. And now, for example, in our enterprise project, one of our enterprise projects, we have this case when extracting new features is just like semi-automatic, I would say. Like you just take it out for another package and it just works. And also, if you want to encapsulate your private code and you don't want it to be like used by others, and you want to avoid the dependency hell, you can expose your public interface in the public package. So we do onboarding public or onboarding interface, and there are only classes that are exposed to other teams because there may be people that are not even in our company or people that we don't know. And we just expose this interface with some facades or classes that actually may use our implementation, but those people don't have to know that. They just know that they can use this set of methods and properties. So it's scalable from the scratch. What it means that feature-based architecture stays the same. It's just recursive. If it's too big, you just make another package and another package with features and sub-features and so on. We just split it by domain. And if the feature is large, it's actually it's like the notion for you that it might be its own package, and you can expose your public interface for others.
So another what if? So what if we are dealing with very complex forms in our application? Because almost every app has some forms. If it's a simple form with like 2 text fields and a button, it's really easy to do with Flutter. But we learned the hard way that, for example, banking transfer forms can be really hard. They had a lot of logic, a lot of asynchronous validation, dependencies between fields. They're also just very long, typically. And we actually ended up, we couldn't find any solution that filled all of the requirements in those projects. They were big enterprise projects. And we ended up actually building 2 custom form solutions independently in 2 of our projects. And then we wanted to combine those experiences and actually come up with something that can be reused in our further projects. So that's how LeanCode Forms came about. It's quite new. The main goal is to get rid of text editing controllers, focus nodes that we don't really want to deal with, especially if we have like 10 text fields. It supports features like scroll to first error, which is actually very hard to achieve with existing libraries and tools, and something that was a very hard requirement in our projects. It also supports conditional fields depending on each other, things like asynchronous validation. And we don't really have time to get very deep into that, but to just give you a preview. This is, again, based on qubits underneath, although, to be honest, this is just an implementation detail. So this suffix, we can actually, I think we'll skip it at some point because you don't really need to use block in your app to be able to use LeanCode Forms. But you declare your form using form group qubit. Here you can see a form that has 2 fields, email and password. And you just declare them again as field qubits, so qubits that handle state of a single field. You can also declare validators, like you need validation in every form. And on the UI level, this would be used again using useBlock hook in our projects. And similarly to what Material does, we have some wrappers. So we have app text form field in place of app text field. And there you can pass field which comes from this form qubit, which is just another qubit underneath. So the whole form actually looks pretty simple. How does it scale? So we really wanted it to be easy to integrate with custom components that you might have in your application. So this is, for example, some boilerplate needed to make it work with app checkbox, something that comes from our design system package. It is some boilerplate, but you just write it once. It's also pretty simple to write. And you can wrap all of your UI components to be able to easily use them in forms. And another very important aspect for scalability is subforms. So if we had this form group qubit, but it was a very complex form, you could still easily end up with like 1,000 lines of code in one qubit. And it's also not so easy to extract to a new class or something. So LeanCode forms supports subforms. So you can actually split your form code into smaller classes, which just group related fields together. And that way you can use it for very complex forms.
Yeah, one last thing. What if we have some reactive data? It's actually pretty straightforward. We also had it in a couple of projects. The scenario, like for example, you have matches and you have some live info about match, like UEFA Euro right now, and you can have a WebSocket, for example, that provides a live stream of data about the score. And also you want some backup, so you have some fetcher that, for example, fetches it like if with a old school HTTP request every 10 seconds, and you combine it in a data source. And just you expose a stream of combined data into your qubit, and then you have your page. So with feature-based architecture, it's still very, I would say, transparent, because everything is contained in your feature directory. If you have anything that's not related to this feature, because, for example, you want to have some infrastructure about offline cache or WebSockets-based classes, you can have them outside of your features folder. You then create a data directory next to features. But if it's related to the feature, as you can see, live info is just a sub-feature of a match. And it's still split into layers. You can do it, but on the local way, so that because layer-based architecture on this local level, it's pretty doing well because you just have a couple of files. So you have 2 files related to blocks, 3 related to data, 1 model, and some widget. So it's still easy to look around and navigate in a sub-feature. Also, you can share widgets between some features in a sub-feature. For example, match summary tile can be used in probably some match history, past matches, and live match. So as you can see, it's not in some global widgets directory with all of the widgets, because it's only related to matches. So it's still in a match feature. Yeah, if you have to add another data source, like, I don't know, offline, you just add it to your data, and it's still like contained inside. If it gets too big or you want it in other app, you extract the feature. So to just summarize our talk, we just think that this is the blueprint, and we can create a tailored architecture for your use case, because there are no silver bullets, but this is something that really makes us happy and works for us. It's not like the best solution. There are many other solutions, but this is something that just works, and we can create a lot of apps with it. And there's even more, because we don't have much time. But we also have the utilities with block. We also have block presentation for side effects, block lens for a bit of functional programming. Those 2 have the talks today in the afternoon, actually. And we have Patrol, maybe some of you know it, and some tools for localization, some tools about the CI/CD stuff, and many more. If you want to know more about them, you can come to our LeanCode booth. We have open source corner with some challenges. And last but not least, I would just want to mention our Flutter CTO report, which is really important stuff, in my opinion. It's first of its kind, because we gathered information from decision makers, CTOs, head of engineering, tech leads about that used Flutter already. How is their experience? And if you know someone that wants to make informed data-driven decision, have to make a decision about what tech stack they need for their apps, and they are considering Flutter, I think this is one of the best things that you can send to them. So let it just, be in the network, and you can scan it. You can also come to our booth. So yeah, I think that's it. Thank you very much. Do you have any questions?